Number 270 is asking for what is the equation of the line. And so I'm just going to have to find the slope using slope formula. And I notice that 0, 1 is my y-intercept, so I can directly go into slope-intercept form. If you didn't recognize that, you could also use point-slope form and simply distribute and solve for y, and you end up at the same spot. 272, we are looking to get to sigma. So the first thing you want to do is figure out the difference, figure out if it's linear. And then you can use summation notation, and you can let k equal 1. Now you will need to adjust your argument for k is equal to 1. So it's going to be 4k, and then you can also count the number of terms, which is 5. If I wanted to start where k is equal to 0, then I need to adjust my argument. And again, you could utilize point slope form for this and pick those numbers, or you can just subtract, or add the difference one more time. And so you can just double check that value, and then your ending index is going to be 1 less. On B, you have to figure out what the pattern is, and in this pattern there's no common difference. They actually multiplied by 2, so you have to figure out your pattern, and the pattern is going to be the base of 2 to a power. And so if we are going to let k equal 0, then you can actually calculate the number of terms. There's 6 terms, but you have to subtract 1, and so that's going to give you 5. And you can always double check this by going 5 minus 0 and then add 1. And if we wanted to do this where k is equal to 1, then we need to adjust the argument to be 2 to the power of k minus 1, and then adjust that ending value to be 6. On C, we can recognize the common difference is 2, so we could end up having the difference right there in the argument and the starting point right there, and we would let that be k is equal to 0. And to figure out the ending value, set the argument equal to the last term to figure out the actual value of B, the ending value. In this case, it's 99. Now, if we wanted to start where k is equal to 1, then it would just be 2k, and then again, the ending value is going to end up being 100 in this case. On 273, this is kind of the setup that they were talking us through. It says to draw a line. He's walking at 4 miles an hour for 1 hour. He's walking at that constant speed, and then it's saying to draw that line and shade in that area. On B, it was asking, explain why the domain will only be between 0 and 1. It's because he only walked for an hour. And the range, the range of this function is just going to be 0 to 4. 0 to 4 miles. So on C, it was asking you to figure out your units. Well, the x-axis is hours and the y-axis is miles per hour. So the area is actually represented by miles, and the area of this particular region is going to be 4 miles. On 74A, the first thing you want to do is figure out what they have in common, and then you put the leftovers, and then we want to simplify that. Now pay attention, because that second factor has another GCF. So we need to pull out that 2, put it out in front, and then the leftovers are in that last term. On B, we're going to pull out that GCF, 2x minus 1 squared, and the leftovers go inside. Remember, you only have 2x minus 1 that's left over, and then we just need to simplify. Nothing else we can do with that, so we're done. On C, the GCF is 2x minus 1 to the power of 3. So that means you have 2x minus 1 to the power of 2 as your leftovers. And then what we need to do from there is just simplify that, multiply that out, and then I want you to combine like terms, and you end up getting this result. 275, the first thing you want to do when you have to solve is see if you can factor anything out. So I'm going to factor this. You can group, or you can recognize that the factors are going to be x minus 5 and x plus 2. Set each factor equal to 0 and solve for x. On 276, we're having to graph the f of x function. So I'm graphing the parabola first, opened circle at 2. So when you plug in 2 into x squared, you get 4. and then I'm going to have that arrow going on towards negative infinity, and then that's a constant at 4 for those values that are less. So this is f of x. G of x says to take that f function and move it up 2 units. So I am literally just moving every single one of those points up 2 units, and then the 4 is just going to become a 6 now, and then it's just going to the right. Then I'm now going to take the f function, move it 3 units to the right, so you can see that I'm moving each point over 3 units to the right, and then sketching that, and then also that 4 goes to the right. The next part was to come up with the equation. So remember, we're just changing those y values. So it's x squared plus 2, and then it was 4 plus 2, which you can simplify to 6. And then k of x is having you go to the right, so we're replacing x and putting x minus 3 squared, because that was the original function, and we're just replacing the argument. And the 4 is going to just remain the 4, because there is no x value that needs changing. The only thing that you're fixing really in that is the domain. So on 277, we need a common denominator, so x minus 1, x plus 1. Going to multiply the top one by x plus 1, the other one by x minus 1. Now I'm just multiplying it out, and then I'm going to start by combining like terms when I'm done, and we get 2x squared plus 2x plus 2 over that common denominator. Okay, common denominator is going to be a minus b, a plus b, and I'm going to multiply the top numerator, or the first numerator, by a plus b, and then I just distribute that. The second numerator I'm going to multiply by a minus b, and then I distribute that. I want you to combine like terms, and we end up getting 2ac as my new numerator. Okay, my common denominator in this case is 6x squared, which means I have to multiply that top numerator, first numerator, by 2x, and then I end up getting 2x squared plus 4x. Notice I don't have to multiply the second numerator by anything, but pay attention, it's a binomial, you have to distribute that negative. Now I want you to combine like terms, and there's your final result.